Hi guys, welcome to Algebra 1 and Lesson 33. This is a super fun lesson, in my opinion. I think it's really easy, so I hope that you like it too. Alright, look up here, I have 210. In last week's lesson we talked about dividing by prime numbers so that you could find out what all the prime factors are of a number. Well, the prime factors of 210 are 2, 3, 5, 7. So I could write out 210 that way. Well, some numbers, we call them they have numerical factors, and some numbers have factors that are letters. So we use the word algebraic factors when we include letters. So if I want to write out this number that has letters with it, 210 x y squared z3, according to its algebraic factors, I'm going to write out its prime factors and then in each of the letter variables that I have as factors. So that would look like this. I already know that 210 is 2 times 3 times 5 times 7. Then I have 1x times 2y's and 3z's. So those are all of my factors of that particular number. I can use my knowledge of these factors in order to find the greatest common factor of several terms that include both letters and numbers for their factors. Okay, let's look at this example. 6x squared y squared m squared plus 3xy cubed m squared plus 3x cubed y squared. If I were to write this out according to its algebraic factors, I would have 2 times 3 for 6, 2 x's, 2 y's, 2 m's. Then I have 3, 1x, 3 y's, 2 m's, a 3, 3 x's, and 2 y's. Okay, remember, we've already talked about how to find the greatest common factor through primes. So remember that the greatest common factor of two or more terms, that's the product of all the prime factors that are in common in a term, the greatest number of times that they are used in that term, along with the highest, well, basically it's, let me start that again. Okay, let me read the definition from your box and then talk you through from there. The greatest common factor of two or more terms is the product of all prime algebraic factors common to every term. So that means that the factors are the same in each one of your terms. Each of your terms contains that factor, each to the highest power that it occurs in all of the terms. Okay, so let me show you. Looking here at this example, look first at our numerical factors. Here I have 2 times 3, 3, and 3. What factors are common in all three of them? The 3, right? I have a 3 here, a 3 here, and a 3 here. I do not have a 2 over in this term or in this term. So only the 3 is a common factor. So the start of my greatest common factor is that 3. Now let's look at the numbers, or excuse me, the letters. Okay, let's start with the x's. Here I have 2 x's. Here I have 1x, and here I have 3. Do I have x in every term? Yes, I do. What's the greatest number of times that it's used in every term? Well, here it's used twice, here it's used once, and here it's used 3 times. So I have at least 2 x's here and 2 x's here, so should it be x squared? No, because here I only have 1x. So the greatest amount of times that x is in all of the terms is only once. I have at least 1x, but I don't have more than 1 in every single term. So I only have 1x in my greatest common factor. Okay, how about the y's? I have 2 y's here, 3 y's here, and 2 y's here. What's the greatest number of times it's used in all 3 terms? Twice. Yes, it is used 3 times here, but it's not used 3 times here or here. So twice is the greatest number of times it's used in each term. All right, and the last one would be the m's. aren't any m's over here. So can I include m in my greatest common factor? No, I can't, because it doesn't even exist in that third term, just like the 2 didn't exist in these two terms. So no m's. So this right here is your greatest common factor, 3xy squared. And we'll work more with that in our next lesson. But hang tight, let's do some examples. Okay, so let's talk through a couple of examples. Here I have 8z4m2p minus 12z3m4p2. For these particular examples, we are not going to write out our factors like we did in the one before. You're probably thinking, oh, thank goodness, because that seemed like a lot of work. Yes, it is. It's not necessary. All right, first I want to look at the 8 and the 12. First, put those into prime factors, okay? That you will want to write out just so that you know what they are, okay? The prime factors of 8 are 2 times 2 times 2. Can you see that? No, not very well. Let me change the color. Okay. Can't grab my marker. Okay. So 2 times 2 times 2. For 12, they are 2 times 2 times 3. Okay? I have 3 2's here, 2 2's, and a 3. 3 is not common in both, so it's not going to be part of my greatest common factor. I do have 2 2's and 2 2's. So 2 times is part of my greatest common factor. What is 2 times 2? It's 4. So that term would be 4. Instead of writing 2 times 2, I can just combine it. 2 times 2 is 4. Right now, let's focus on the letters. Z4, let's focus on Z first. I have Z4 and Z3. Well, that means that the greatest time Z appears in both of them is 3 times, okay? Because it can't appear 4 times in my second term. It's only there 3 times. So the greatest is Z3. So basically that means that you're looking for the variable that has the smallest prime factor, has the smallest exponent. The variable with the smallest exponent will be the variable in your greatest common factor, as long as that variable is in each term, okay? So what do I mean by that? M2, M4. Which variable has the smaller exponent? M2. Since M is in both terms, that means M2 is in the greatest common factor. P, P2. Which one has the smallest exponent? P. Since P is in both of my terms, then yes, it can be part of my greatest common factor. So that would be 4Z3M2P. All right, let's do the next one. 4x squared y3z minus 8y squared xz3. So the prime factors of 4 are 2 times 2. 8 we know is 2 times 2 times 2. So the greatest number of times that we see 2 in both terms would be twice. So 2 times 2 is 4. Okay, moving on now. We see x squared and 1x. 1x is the smaller exponent, so 1x. y3, y2. y2 is smaller exponent, so y2. z, z3. z has the smaller exponent, so z. Okay, now we're moving on to one with 3 terms. Let's see how we do here. Okay, starting with our coefficients. 16 is 2 times 2 times 2 times 2, right? Yeah. 4 is 2 times 2, and 2, of course, is just 2. Well, that's the smallest one. 2 only one time, so my greatest common factor, the coefficient, the number, would start with 2. All right, now let's do our variables. Here I have x2, x3, x2. What's the smallest variable, or smallest exponent? x2, very good. Okay, let's go to y. y, y2, y2. What's the smallest exponent? Just y. Okay, p3, p, p15. What's the smallest exponent? Just p. All right, there you have it, and that's all. So that's all you have to do. It's that simple. Okay, pause now to do your practice. Okay, you should be back now, ready to go. Letter A, 2xy3m. Letter B, 5a squared, b squared, c squared. C, 4xyp3. All right, let me know if you're having any trouble, if you need me to do more examples for you, because we are going to build on this in tomorrow's lesson. So if you don't understand this, please let me know, because otherwise you're going to have trouble with tomorrow's lesson. If you've got it, if you think it's fun and easy like I do, woohoo, good for you. All right, so you're perfectly ready for tomorrow. Okay, have a great day. Love you very much. Bye.